Units of rotary motion. So here we have two different units for angles. We can either present an angle in degrees or we can present an angle in radians. Important to remember that one oscillation is equal to 360 degrees, which is equal to 2 pi radians. You convert between these two different units of angles by using the two formulas you see on your screen. To get an angle in radians, if you have an angle in degrees, multiply it by pi radians and divide it by 180 degrees. And if you have an angle in radians that you want in degrees, multiply it by 180 degrees and divide by pi radians. Now, 1 revolution per minute is a unit of angular frequency, sometimes called angular velocity. That means you have done one complete oscillation, or 360 degrees, or 2 pi radians, and it's taken 1 minute to do that. So to find what the angular frequency is equivalent to in radians per second, 1 revolution per minute is 2 pi radians, and that's taken 60 seconds. That gives you revolutions per minute of 0.1047 to 4 significant figures, radians per second. If you wanted to do it in degrees per second, then it would be 360 degrees divided by 60 seconds, and that's just 6 degrees per second. Now, angular frequency and frequency are related through this equation you see on the screen. Remember, frequency is the reciprocal of your time period, and angular frequency, which will give the letter omega, is theta divided by t, or an angle that you've moved through divided by the time it's taken you to move through that angle. If we consider one full rotation, one complete oscillation of 2 pi radians, then the time that it's taken to move through that angle will be the time period, capital T. That gives us the equation omega equals 2 pi f. So let's practice converting some units. 5 radians is 5, and I'll write it out in full, radians, multiplied by 180 degrees divided by pi radians. And the reason why I've written it out full is so that I can cancel my units of radians, and I can see that what I'm left with is degrees. So that gives me 5 times 180, which is 286.5 degrees. Now we try to convert it the other way around. So let's say we've got 270 degrees. So let's write that out in full. 270 degrees multiplied by pi radians divided by 180 degrees. That way I can cancel the degrees, and what I'm left with is my radians as a unit. And 270 multiplied by pi divided by 180 is 4.71 radians. Next we have a case where we've got a few different variables to calculate, and we know that the time period is the reciprocal of the frequency, so the frequency is the reciprocal of the time period, which in this case is 50 Hertz. Now the angular frequency is going to be 2 times pi multiplied by that 50 Hertz, which is going to give me 314.2 radians per second. Now for revolutions per minute, we're going to write down that one oscillation, or one revolution, has taken 0.02 seconds. But of course I want it in oscillations per minute, or revolutions per minute. So I have to multiply this by a number that gets rid of the seconds. Now 60 seconds is equal to 1 minute. This allows me to cancel the seconds. And what I'm left with is 60 divided by 0.02, and that will be in revolutions per minute, which is 3,000 revolutions per minute. And finally, let's imagine that we've got our angular frequency and our radius, and we want to know the speed of a body that's orbiting with that angular frequency and at that radius. Well, remember, speed is distance over time. And the distance that the particle has moved is 2 pi r, the circumference of a circle, and the time it's taken to move that distance is the time period. And the reciprocal of time period is the frequency. And of course 2 pi f is equal to omega. So I can multiply together the angular frequency, that's 2 pi, with the radius, that's 2. And that gives me 4 pi, or 12.57 meters per second.